Hi, I'm going to show you my infrared image processing unit that consists of 5 algorithms that can be applied in any number or order to the input image in a software configurable manner. First of all, let's see the Vivado project. I extended an existing demo, the PCAM5C demo, where I inserted my module between the gamma correction and the VDMA. I connected my module to all this schematic in Verilog. I also added some FIFOs because as you saw in the diagram, all of my processing elements need to communicate with some FIFOs. And for the configuration part, I used the APB interface, so I had to add an APB bridge. Let's see the software. How does the configuration works? At each algorithm can set what processing element, how to receive its input. As shown in this diagram, I can set this processing element's input as being this processing element's output or the global input. If everything is set to 0, that means the global input will be sent directly to the output. Prior to this, I've done some recording. This is my setup with a Raspberry Pi cam and the FPGA. My test subject. You can see that this camera isn't a true infrared camera. This is an RGB image, and for this I've made a special cap that will block any visible light, and I will obtain only the IR image. Now there are no more colors. If I want to apply a filter to the image, let's say I want to do an edge detection. My 5 algorithms, by the way: depth pixel correction, image sharpening, image smoothing, medium filtering, edge detection using the Laplacian filter, and another selection is the output selector. If I want to use edge detection, I will set the edge detection's input the global input. This doesn't mean that the edge detection's output will be wired to its input. This means it will be the global input, and for the output I have to select the Laplacian filter's output. This is how it looks like with the cap. You can see the edges, but there's a lot of noise in the image. To eliminate this noise, I've added another filter to it, the smoothing filter that can smooth out the noise. If I add the global input to the smoothing filter and set the edge detection input to the smoothing filter's output, this is how my image looks like. You can see there are now only edges. The noise got smoothed out, but the edges aren't as sharp as they were before. I hard-coded some configurations to the switches. Here's the table. And I added a split screen functionality so I can compare the original image to the processed one, and here's a picture of it. So, thank you for watching.